For this last example, we're given this number, 73,486,300D. And it says use divisibility test to give all the choices of D by which this number M is divisible by these different numbers. So some of these are going to be quicker than others. So I'm going to start with what I think are probably the two easiest, 5 and 10, down here at the bottom. To be divisible by 5, the last digit needs to be a 0 or a 5. So for this number M to be divisible by 5, that digit D needs to either be a 0 or a 5. For the number M to be divisible by 10, it's even more restrictive. D must be a 0. So those two are now done. So I'm going to move up to the 2. For M to be divisible by 2, its last digit must be even. So that means that D needs to equal 0, 2, 4, 6, or 8. I'm now going to jump down to 4, and then I'll look at 8, and we'll come back to 3 and 6. To be divisible by 4, the last two digits must be divisible by 4. Now, the other thing, to be divisible by 4, has to also be divisible by 2. So I don't need to check every single value for D, just 0, 2, 4, 6, 8. So if D is 0, we have 0, 0. Well, yes, 0 is divisible by 4, so D could be 0. If D is 2, we have 0, 2, so 2. 2 is not divisible by 4. It's a fraction. So we check 4. 4 is divisible by 4. 6 is not, but 8 is. So if D is equal to 0, 4, or 8, M in its entirety is divisible by 4. So I want to jump now to the 8. We want to see what values of D would allow M to be divisible by 8. To be divisible by 8, it must also be divisible by 4. So we can limit our choices to just 0, 4, and 8. So we just need to check these three numbers for D. Divisibility by 8 says that if the last three digits are divisible by 8, so is the whole number. So we're going to check 3, 0, 0 first. 300. Is 300 divisible by 8? It is not. You can check that on a calculator. It's not evenly divisible. So then we check the next one, 304. Is that divisible by 8? Yes, it is. And then 308, that is not divisible by 8. So for M to be divisible by 8, there's only one choice for that last digit. It has to be a 4. Now I want to go back to the 3. So I skipped the 3 earlier. To be divisible by 3, the sum of all of the digits must be divisible by 3. So I'm going to sum up everything except for D real quick. Just let's make life a little easier on ourselves. So 7 plus 3 is 10. Let's use some of our tips and tricks that we've learned. We have 10, 4 and 6 make another 10, so that's 20, 28, 29, 30, 31. Obviously 0 doesn't change anything. So all of these are equal to 31. For the entire number to be divisible by 3, 31 plus whatever D is has to be divisible by 3. If D is 0, we're still at 31. That is not divisible by 3. If D is equal to 1, 31 plus 1 is 32, still not divisible by 3. If D is equal to 2, we have 31 plus 2, which is 33. 33 is divisible by 3, so D could equal 2. And we'll keep going. If D is 3, we have 31 plus 3 or 34. That's no good. If D is 4, we have 31 plus 4 or 35. Again, that doesn't work. If D is 5, we're going to have a winner. 31 plus 5 is 36, and 36 is divisible by 3. D is 6. 31 plus 6 is 37. If D is 7, 31 plus 7 is 38. Still doesn't work. If D is 8, we have 31 plus 8, or 39. 39 is divisible by 3. And then if D is 9, 31 plus 9 is 40, and that also does not work. So if D is 2, 5, or 8, the entire number M is divisible by 3. Almost done now. 6 and 9. To be divisible by 6, it has to be divisible by both 2 and 3. So you just look at what 2 and 3 have in common here. What values of D do they have in common? Just the 2 and the 8. And then finally, for divisibility by 9. For the number to be divisible by 9, two things have to happen. It first must be divisible by 3, so that limits our choices to just 2, 5, and 8 for D. And the sum of the digits has to be divisible by 9. So if I check the 2, 31 plus 2 is 33. That is not divisible by 9. 5, 31 plus 5 is 36. That is divisible by 9. And then 8, 31 plus 8 is 39. 39 is not divisible by 9. So for the number M to be divisible by 9, its last digit needs to be a 5.